Hey everybody, this is Larry. This is day 18 of the LeetCode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm or just any farm in general. And everything setup is a little bit weird today, but hopefully that's okay. And usually I set these live, so if it goes a little bit slow, just fast forward or I don't know, watch it in 2x or whatever you like. Okay, so today's farm is arithmetic slices. Okay, it has three numbers, and okay, so that makes sense. I mean, I know what an arithmetic sequence is, but so we're given an array. A slice is of that array is any pairs of integer. Yeah, this is very awkwardly phrased. Must be an old written problem or written a long time ago. Okay, so it's just a slice. Okay, the number of arithmetic slices in A. Okay, so it has to be. I guess the thing that I was checking for was whether it was contiguous. There are only 3 slices in A. Is that right? Oh, at least 3 elements. That's right. Oh, okay. I was trying to figure out why this was only 3, but it was because there's only 3 elements. So okay. So this is actually a tricky problem. I have seen similar ones before. It's not always arithmetic, but it's sometimes something similar. I think I saw something, I don't know about recently, but maybe in the last year or two. So basically the idea is going to be, oh wait, this is consecutive, right? Okay. Well, I mean, this is contiguous, right? So okay. So I was thinking about the one where it's not contiguous, so maybe I did misspeak about thinking about that. But I think there should be straightforward because it's arithmetic. You can do some sort of greedy / sliding window. I think it's just about counting for math. Because yeah, I mean, I think it's just math and counting. Because basically, the idea is that for every point, you just keep on tracking whether, yeah, it's just greedy. I think that's okay, and it's just about tracking what's the longest current contiguous arithmetic sequence. And once you have that sequence, you could just do math to do the count. Because let's say you have a sequence of length 4, or maybe even let's make a string longer. Let's say we have a string of length 7. When we add the 7, what does that mean, right? That means that we actually get to that means that there's a sequence of length 7, also a sequence of length 6, also a length of 5 and 4 and 3, right? So once we do that math, we can just do that sum that way. I think this is okay. Okay, so let's do a count is equal to 0. We return count at the end. So the thing that I'm looking for now is just checking for the size of n. They don't give it to you, but because this could be at worst n square, right? And because this could be n square, it overflows int if it's greater than the square root of 2 to the 32 or something, or 31st, I guess. But because they don't tell you, and usually sometimes, or at least recently, they've been saying that if it overflows in, it just ask you to mod the numbers. I was just looking to see if there's a mod or anything, but for now, because they don't tell you, I assume that n is going to be small. But this is going to be a linear time algorithm anyway, so I don't really worry about complexity or time complexity rather. So okay, let's just say delta is equal to some random number that's not going to hit. So let's just do full of infinity. I think that's how you do infinity in Python. And then now we just look at every two numbers, right? And then maybe we just keep track of length. Is length is equal to let's just say 1, right? Or yeah, let's just say 1 because maybe 2. And the reason is and the reason is just try to figure out what the default is. We'll work through what it means because for now we might have to change this later. I don't know, but yeah, for now, and then now we look at every 2 consecutive numbers. So usually the way that I do it in Python is something like this. Though I think this is maybe a little bit harder to read for a beginner, so I'm going to just rewrite it a little bit just for educational purposes. So we set index is 0, 0, n is equal to length of a, and then now we do a for loop. I don't actually need to set index in range sub n minus 1. I guess I don't need that here. And then we have x is equal to a of index, and y is equal to a of index plus 1, right? And then now, if I always write, I guess y minus x or x minus y doesn't matter as long as it's consistent. If it is equal to delta, then we just increment the length. Else, length is equal to 2 because you have two numbers, and delta is equal to y minus x. And then now after that we just do the count. We add it to the max of length minus 3 and then 0. That's just to check it's 0, right? Is this length minus 3 or length minus 2? So if you have 3, if the length is 3, you want 1. The length, this is as we said before, right? The way that we get it is that, let's say our current length is what is length? I think we want to define that currently. What is length? Length is the longest sequence, arithmetic sequence that ends at the current index, right? And because of that, as we said, if we have 1, 2, 3, 4, 5, if we're at 5 and the longest arithmetic sequence is 5, that means that there's 3 that we want to add to this, right? Because there's a one of length 5, one of length 4, one of length 3, right? So that's basically where this number comes from. I hope this is right, so I'm explaining a lot of it wrong. So let's give it, oh, they don't give us test cases. Okay, fine. More than just this one. And then, yeah, maybe more. Something like that, maybe. And what can it be? Yeah, okay, looks good. I don't know one number. Let's also do. So I mean, I don't expect anything. I don't expect these to give me the wrong answer because I don't think these are really special cases. So let's give it a submit. Cool. Yeah. So what is the complexity as we talked about? Because this, I mean, you could kind of see it here, right? It's a for loop, so this is going to be O of n. In terms of space, we only use we only use constant extra space. We just have variables, right? So yeah, so linear time, constant space. Let me know what you think. It's definitely, I definitely feel like I made this look easier than it is. It is tricky. I think it's just that I worked, like in competitive, these kind of problems a few times, and that's kind of the idea. The ideas here are the things that I, we use. So definitely if you're having trouble, like, take your time and yeah, take your time. Yeah, that's all I have for this because I just woke up and I am a little bit hungry. But yeah, take care. I'll see y'all tomorrow. Stay safe, stay good, to good health and to good mental health. I'll see you tomorrow. Bye-bye.